This is question 8, 2012 Higher Maths Paper 1. You're given the volume of a sphere formula, volume 4/3 pi r cubed, r being the radius, and you're asked what the rate of change of v is with respect to r for a particular value of r. Now, the language involved in this, let's think of, this is not the correct graph, but let's suppose that this graph looks a bit like this, that as the radius increase, you can imagine a sphere, and the radius is getting larger and larger, and so is the volume, and an increase of 1 in the radius, say, would result in this sort of increase in the volume from there to there. So an increase of 1 unit in the radius would increase the volume by this amount. Now, at this particular point, if the graph continued at that steepness, one along this distance up, it might well be 1 unit. So at this particular point, we would say that the volume is increasing at 1 unit per unit increase in the radius. Along here, for instance, further along the graph, that seems a lot steeper, this line. And in this case, if we had 1 unit increase in the radius, then we maybe have about, say, 4 units increase in the volume. So the volume is increasing faster, 4 units of volume increase per 1 unit increase in the radius. Now, you'll recognize maybe that these tangents to this curve, and what we're doing is really just working out the gradients of these tangents, 1 along, 1 up, in this case 1 along 4 up. So we really need to find out what the gradient of this curve is. So we're looking at v equals 4/3 pi r cubed and asking what the gradient is. Now, we normally have something like y equals, say, 4x cubed, and the gradient we can easily differentiate. Bring this index down, 3 times 4 is 12, 1 less, so it's 12x squared. A similar sort of thing will go on here. This 4/3 of pi, remember pi is just a wee bit more than 3, so this would be just a wee bit more than 4, maybe about 4.2. We could say that it's approximately 4.2 r cubed. Now, if you were differentiating that, if it was a y equals 4.2x cubed, you would say, oh wow, dy by dx, that's 3 times 4.2, that's 12.6x squared. So you're multiplying this number by the 3 and then taking 1 away from the 3. And instead of instead of y, we have a v, instead of x, we have an r. So dy by dx would then be dv by dr. And we would proceed with 3 times this number, r squared. So let me just get rid of all this and proceed. Okay, so v equals 4/3 of pi, just a single number, times r cubed. dv by dr equals, and remember from my explanation a minute ago, it could be something like this, where we would have dy by dx equals 12.6x squared. So it's 3 times the number 4/3 of pi, and that is just a number, times r squared. The 3's cancel, and we're left with the 4. 3 times 4/3 is just 4. Pi r squared. So that's what dv by dr is. So this is the rate at which v changes with respect to r. It's the gradient of the volume against radius graph. It's the rate at which these values change. One along here, how far up does it go? What is the gradient at this particular point? Now we're asked, what is the rate of change of v when r is 2? We want to know the tangent at this one, at this point where r equals 2. We want to know what the gradient is. We want to know how far up this line has gone. So this is the gradient formula, 4 pi r squared. And we have to say that when r equals 2, the gradient of this tangent, when r is 2, is equal to 4 pi times 2 squared. 4 pi times 4. That's 16 pi. So basically, 1 unit along, 1 unit increase for r, the volume has increased by 16 pi. That's just over 3, that's about just over 48 units for the volume. So that's what's happening in the sphere when the radius is size 2 and it's still increasing. That's the rate at that particular point, the rate at which the volume of the sphere is increasing. So 16 pi, let's have a look at the choices that were given, and there it is, it's choice C.